Welcome to today's lesson on solving one-step equations. In this lesson, we'll learn how to tackle equations with only one variable on one side of the equal symbol. By the end of this lesson, you'll be a one-step equation whiz. Let's get started. Ready to level up your algebra skills? Today's adventure is all about conquering one-step equations and their secret weapon, inverse operations. Don't worry. These guys are way cooler than they sound. We are about to answer 3 key questions. First, what's the deal with one-step equations? We'll crack the code and see how to solve them in a flash. Second, inverse operations, what are they, and why should you care? Think of them as your math superpowers. Third, will this stuff ever come in handy outside of class? Spoiler alert, you bet it will. Remember, math builds on itself, like a giant knowledge pyramid. So, if you've been a rock star in the previous lessons, this will be a breeze. If some things feel a little wobbly, no sweat. Just go back and review the earlier lessons. Trust me, a quick refresher will make you feel confident in no time. Alright, enough chit-chat. Let's dive into the world of one-step equations and inverse operations. A one-step equation is a simple algebraic equation that can be solved in a single step. This involves performing one operation, addition, subtraction, multiplication, or division, to isolate the variable on one side of the equation. Imagine you're a detective trying to crack a secret code. A one-step equation is like a hidden message, with one number locked away. You must use detective skills and cool math moves to find that secret number. Here's the breakdown. First, the equation is the code. It has numbers, letters like x, and an equal sign. If there is no equal sign, it is an expression. It's not an equation. Expressions may be simplified, but only equations can be solved. The variable, usually a letter, is the suspect. We don't know its value yet, but want to find it. The numbers and signs are the clues. They tell us what operations, like addition or subtraction, to unlock the secret number disguised as the variable. The cool part about a one-step equation is that you only need one detective move, one operation, to crack the code. X plus 7 is an expression. It combines numbers, variables, and mathematical operators, such as addition or multiplication. Since it does not include an equal sign, we are not instructed to find the value of x. Expressions can be simplified or evaluated, but they do not have a solution. In the case of x plus 7, we say the problem is simplified because there is nothing else to do. X plus 7 is equal to 10 is an equation. This is a mathematical statement that asserts the equality of two expressions. It includes an equal sign and can be solved to find the variable's value. In this case, to solve the equation, you would isolate the x by using inverse operation. Something we will learn next. One-step equations, challenge accepted. One-step equations are like the ultimate math challenges, where you only need one super move to win. Ready to test your skills? I bet you can solve these with ease. 1. Mystery number addition. We have a secret number, let's call it x. If we add 3 to x, we get 10. What is the value of x? 2. Subtraction showdown. We start with a number and subtract 3 to get 10. What number are we starting with? 3. Double trouble. Hash a mysterious number doubles and becomes 10. Can you uncover the original number? 4. Half-time hero. We have a grand total of 10, but that's actually double the value of our secret number. What's the hidden number that's half of 10? It is think time. Pause the video and answer the questions below on your own. We'll check the answers together on the next slide. Here are the secret numbers. 7 added to 3 equals 10. 13 subtracted by 3 equals 10. Doubling 5 gives you 10. And half of 10 is, of course, 5. These might seem like easy problems to solve in your head, but here's the real superpower. Inverse operations, your math problem-solving toolkit. While figuring things out in your head is excellent, there's a better way to solve equations, especially when they get trickier. That's where inverse operations come in. Think of them as special math moves that help you crack any equation code, just like a superhero with incredible powers. Learning about inverse operations will be like having a secret weapon in your math toolbox. It'll help you solve more complex problems and sharpen your problem-solving skills in general. Pretty neat, right? So, get ready to unlock these math superpowers next. Remember those math moves we mastered in PEMDAS and distribution lessons. Addition, subtraction, multiplication, and division. Today's adventure is all about inverse operations, which are the secret ninja moves of math. Think of it like this: addition and subtraction are like opposites. Adding something is like taking a step forward, and subtraction is like taking a step back. They undo each other's effects like a math ninja reversing an attack. Multiplication and division are another pair of inverses. Multiplication is like stretching something, division is like shrinking it back to its original size. Pretty cool, right? So, buckle up. We'll learn how these inverse operations work their magic and become even more powerful math problem solvers. We will begin by showing you how to organize your work. It will make work much more manageable and prepare you for more complicated work later. Many people feel overwhelmed by equations. After watching this, you will not be one of them. You will be confident. Today, we'll learn a secret weapon to conquer any equation. That secret is proper organization. Most math courses throw problems at you without a plan. But here's the deal: organization is critical to solving complex equations later. Think of it like building a house. The solid foundation is crucial. Step 1, the big picture problem: write the problem in the large box. This is where we see the entire mystery we need to solve. The problem will already be in your worksheet, but trust me, you'll be writing them down in no time. Step 2, the mystery guessed: identify the variable and write it in the rectangle. Equations often have hidden clues, letters representing unknown values. That's our mystery guessed, the variable. Even if it seems obvious now, writing it down prepares you for trickier problems with multiple variables later. Think of it as labeling the suspects in a detective case. Step 3, the original crime scene: identify and write the operation. What's happening in the equation? Is something being added, subtracted, multiplied, or divided? Identifying this operation is like understanding the crime scene in our detective analogy. It helps us know what needs to be undone to solve the equation. Step 4, undoing the mystery: identify and write the inverse operation. This is where the magic happens. Every operation has an inverse. It is the opposite. Think of it as the undo button in math. Addition's inverse is subtraction, multiplication's is division, and so on. Understanding inverses is a superpower that lets you think logically and solve equations more efficiently. This skill will come in handy later on. Step 5, the big reveal: write the answer in the last box. Here's where we crack the code and find the value of our mystery variable. In this lesson, the answer will be a number, a constant. But remember, as we progress, the answer might involve variables, expressions, or even new equations. So, ditch the idea that all math problems have simple answers. Sometimes, the solution is just the beginning of a new adventure. Before we move on, take a moment to fill out the boxes in your notes. Remember, organization is your key to unlocking the secrets of equations. Once you're done, join me on the next slide to check the answer and see how your detective skills are shaping up. In this problem, we are concerned about the variable x. So, we place it in the box. Later, there will be multiple variables. While that may seem confusing, the work is no different from here. Whatever variable we are concerned about goes in this box. The operation is addition. Multi-step equations have more than one step. That's fine. The process stays the same, we take it one step at a time. The opposite of addition is subtraction. So, we put subtraction in this box. Finally, we subtract 9 from 21 to get 12, our answer. This is correct because the sum of 12 and 9 is 21. On the next slide, we will work a subtraction equation. This problem is like the previous one, except we subtract instead of adding a constant to a variable. Take a moment to think about it, and then pause the video before moving on to the next slide for the answer and explanation. Let's break down this equation. Think about the variable. We are solving for m, so that goes in the variable box. Next, identify the operation. Since subtraction is used, we put subtraction in the operation box. Now, we must undo the operation. To isolate m, we must undo subtraction. Since the opposite of subtraction is addition, we add. Here are two approaches to this type of equation. There are two ways to think about this problem. First, you can ask, what number minus 9 equals 31? This approach is perfectly valid and uses arithmetic reasoning. The other approach asks, what number plus 9 equals 31? This approach uses algebra. By using the inverse operation, addition, to undo the subtraction, we can isolate the variable m and find the correct answer. The answer is found by adding 9 to both sides of the equation, which gives us m plus 9 is equal to 40. Simplifying, we find m equals 40. Alright, let's tackle a new challenge. This time, we are dealing with multiplication. The good news: the process stays the same. We'll still identify the variable and use its inverse operation to isolate it. Ready to test your skills? Pause the video and try solving this multiplication equation on your own. We'll break it down step by step on the next slide. In this equation we are going to isolate b. We are looking for the variable b, which is currently being multiplied by 4. This goes in the variable box. Opposite equals solution. Since multiplication is used, its inverse, the opposite operation, is division. That's our key to solving for b. We are going to divide and conquer. To isolate b, we divide both sides by 4. Dividing 16 by 4 gives us 4. Checking our work. It's always a good idea to double-check our answer. If b equals 4, then multiplying 4 by 4 should give us 16, the original number on the other side of the equation. And guess what? It does. Bonus tip: making connections. Notice that 4 times 4 is also the same as 4 squared. Finding these connections between different mathematical concepts can help build a deeper understanding. Last but not least, division. While some might find it tricky, division is just another tool in your math belt. The key is practice, so don't worry if it doesn't click right away. Ready to put your skills to the test? This problem follows the same process as before. Pause the video and try solving it on your own. We'll break it down step by step on the next slide. Let's isolate w in this equation. We want to find w, which is being divided by 3. This goes in the variable box. Using the opposite operation is the key to finding the solution. Since division is used, its inverse, the opposite operation, is multiplication. That's our key to solving for w. To isolate w, we multiply both sides by 3. Multiplying 2 times 3 gives us 6. Checking our work. It's always a good idea to double-check our answer. If w equals 6, dividing 6 by 2 should give us 3, the original number on the other side of the equation. And guess what? It does. Let's unlock the secret to like terms. These terms are like the school supplies in your backpack. They can be grouped together because they are similar in a few ways. First, they have the same label or variable. Imagine the letters in an equation, like x or y, are labels for your supplies. Terms with the same letter are like terms. They represent the same stuff, just like two packs of pencils with the same brand. Second, they are the same size and on the same team. Sometimes, you might see a tiny number next to the variable, like x squared or y cubed. This is called the exponent, and it acts like a size indicator. Terms with the same variable and the same exponent are also like terms. Picture it like having large highlighters, x squared, and small ones, x to the power of 1, both labeled for art class. Different sizes, but still highlighters. Finally, they are numbers on their own. They are also called constants. Just like your lunchbox doesn't have a fancy label, numbers by themselves, like 3 or -7, are terms too. They are independent players, but still part of the equation. Why are like terms important? Knowing like terms is like having a well-organized desk. When you see them in an equation, you can group them together to make solving the equation much easier. It's like putting your pencils with your pencils and your notebooks with your notebooks. Like terms are your key to success in future math adventures. The upcoming quiz will be a great chance to show off your new skills. So next time you see an equation, remember, same variable, same size exponent, or just a number on its own, those are your like terms, ready to be grouped and conquered. Congratulations! You've unlocked the secrets of one-step equations. Remember, these equations are like puzzles, and you've mastered the art of isolating the variable to find the missing piece. Key takeaways: you can identify the variable and the operation used in the equation. You can use the inverse operation, addition for subtraction, multiplication for division, and vice versa, to isolate the variable. You can simplify the equation to find the final answer. You can always check your solution by plugging your answer back into the original equation. You know the definition of like terms. The world of math is full of exciting challenges, and conquering one-step equations is a big step forward. The next course section will give the opportunity to practice.